So welcome to this brief presentation on drawing ray diagrams. We appreciate that for many teachers that you may not have actually done this yourself when at school. For a few years this had dropped out of GCSE curricula, and consequently I've come across quite a few teachers who have had to teach this, having not met it themselves at GCSE. So what we're going to do, we're going to look at how to construct a ray diagram for a convex and a concave lens, and look at a few of the ways that you can go about it. Again, use this for yourself, use it with colleagues, you may even wish to use it in a classroom. So let's start off with a convex lens, and that's represented by the double-ended arrow in the middle. That's the standard symbol. One tip, draw ray diagrams on graph paper. It makes life an awful lot easier. I've marked on the diagram the focal points of the lens. You'll notice they're either side of the lens, but I've also put on the principal axis the 2F position, as that does have an impact on the image formation location. You'll see that in a subsequent example. So anyway, all we're going to do is look at how to draw two rays from the top of the object. Now, please bear in mind, rays are just a construction invented by physicists. In fact, light being reflected off or emanating from the object goes in all directions over an entire sphere. We just happen to pick out two straight rays. And here's the first one. So draw a ray from the top of the object straight the way through the center of the lens, the point at which it crosses over the principal axis. That's the easy one, and that works with every ray diagram. The next one, start at the top of the object and draw a line parallel to the principal axis until it hits the lens. And then with that, the lens refracts, sorry, not the lens, the ray refracts, and it goes through the focal point. There we go. The point at which those two rays cross represents the top of the image. And so the last step is to draw in the image, which is an arrow. There we have it. And notice there are three things to be said about that image. Firstly, that it is real. You could actually project that onto a screen. It's inverted, it is upside down, and it is reduced. It's smaller than the object. So that's really the basic way of drawing a ray diagram. You'll notice in this case the object was placed beyond 2F, and it gives us this reduced image. So the next diagram, rather than doing it ray by ray, I'm just going to show you the ray diagram. There we go. So this time we've placed the object between the focal point and twice the focal length. And you'll notice this time the ray diagram looks pretty much the same. We've got the ray going through the center of the lens, and we've got the ray that's parallel to the principal axis that passes through the other focal point. But this time they cross beyond 2F on the other side. So the image is again real. You could project it onto a screen. It's inverted. However, now it is magnified. There's one more option. We've done a distance greater than 2F, between F and 2F. So the last one is what happens if you place the object within the focal length. Now that's something a little bit different. What we've got here is a virtual image. What happens, we draw in the ray from the top of the object going through the center of the lens. We then draw the ray parallel to the principal axis and going through the focal point. But notice those two rays are diverging, they're spreading out. So what happens here is a remarkable thing going on in the brain. We reconstruct those inside our brain to imagine they came from a point somewhere behind the actual object. So this time we trace the rays back in space on the left hand side of the lens. That's why I've used a dotted line, to the point again at which they cross over. That image cannot be cast onto a screen. It is virtual. It exists in the head of the observer. It's the right way up, and it's magnified. And this is the ray diagram that works for a magnifying glass. The final thing I want to do in this brief presentation is look at how to draw the ray diagram for a concave lens. The symbol is similar to that for a convex lens, but you'll notice that the arrows go in the other direction. So let's just go through it one ray at a time. I've chosen this time to put the object between the focal length and twice the focal length, not that it massively matters. So as before, draw in the ray going straight from the top of the object through the center of the lens. As before, it's not going to come as any surprise. There's the ray from the top of the object to the lens, parallel to the principal axis. Now, this time, rather than that ray on the right-hand side going through the focal point, it now goes outwards. It diverges. And we can work out the direction it diverges by tracing it through the focal point on the same side of the lens as the object. And what you'll now notice is, again, we've got a point at which the rays cross over. That's where the image is formed. Now, as with the last example on the convex lens, because the image is on the same side as the object, it's actually not really there. It's again reconstructed in the mind of the observer. It's virtual. You'll notice it's upright and it's reduced. So hopefully, if you apply what you've seen on the previous few slides, you should be able to draw any ray diagram.